The basic principle behind finding the inverse is just switching the x and the y around. On the test, I will give you extra credit if you use proper notation. The proper notation for the inverse is a -1 power. So if this is my function f as a set of ordered pairs, my inverse of f is going to be written as f to the -1. So f inverse is equal to another set of ordered pairs. And these ordered pairs are going to switch the x and the y around. So 6, 4. The next one is 1, 0. And the last one, 2, -2. For part B, when I have a function, we want to switch the x and the y around. Here's my x. G of x is my y. So I'm going to switch those two around. X equals 3. And I will call it y just to make it easier. But we're going to go through and solve for y. So add 7 to both sides. X plus 7 equals 3y. So we're going to divide both sides by 3. And we got x plus 7 over 3 is equal to y. Now, of course, it isn't y. It's the inverse of g of x. So use proper notation. G inverse of x is equal to x plus 7 all over 3. With h of x equals the square root of x plus 1, switch the x and the y around. So x equals the square root of y plus 1. And solve it. To get rid of the square root, we're going to square. X squared is equal to y plus 1. Subtract 1. X squared minus 1 is equal to y. And of course, it's not y. It's the inverse of h. So write it as h inverse equals x squared minus 1. And the last one, k of x, switch the y and the x around. So x is equal to y plus 11 all over 4. Multiply both sides by 4. Subtract 11. And 4x minus 11 equals y. But again, it's not y, it's the inverse of k, so write it as k inverse of x is equal to 4x minus 11.